Hi everybody, welcome to this Saturday session with ExamRevision. So this video is for Leaving Cert higher level maths students, and what we're going to focus on today, we're going to do a bit of an introduction to calculus, and we're also then going to move on to first principle exam questions. So what are we going to do? So we're going to look first at the notation, and we're going to see if we can differentiate polynomials. Okay, so that's kind of your basic rule of calculus. We're going to figure out how we write this down and just kind of work on that basic rule. This video isn't going to go past that in terms of rules for calculus. There will be another video about the product rule, the quotient rule, differentiating trig functions, etc. But here we're just going to focus on the basic rule because that's all we need for the other two sections. So then we're going to look at an application of calculus. So the most common question is, what is calculus used for? Calculus can be used for loads of things, but we're going to use it to find the slope of a tangent to a curve. And then we're going to link in coordinate geometry as well there. Just do a very quick revision on finding the equation of a line, which is no harm. And then finally, we're going to move on to differentiating by first principles. Okay, that's going to be the main bulk of this video. And what we're going to do, we're going to write it out in a really structured way. And then we're going to focus on the exam questions. Okay, so we're going to do the exam questions from the last 3 or 4 years of when it's come up. Okay, we'll look at patterns. We're going to look at the marking schemes as well to see how we pick up our marks, what the examiners are looking for, and I guess hopefully that will highlight how important first principles is, because when it comes up it tends to be 15 or 20 marks, which really adds up to quite a lot of your calculus marks for that short question. Okay, so that's going to be the structure. We'll start now with kind of just some basics. You may know this already, but it's no harm to revise it. Just start with our notation. Okay, at the start this can seem very abstract, but really once you start using it, it becomes second nature. So there are two different sets of notation we can use for calculus. They both mean the same thing. Okay, so say you are given a function f of x and you differentiate it. Okay, we'll come to what differentiating is. Okay, for now, just think of it as you're doing an operation to the function. When you differentiate it, you end up with the first derivative, which we call f dash x. Okay. Then if you differentiate that again, we'll end up with the second derivative, and it's f double dash x, okay? Or if they call the function y, okay, so if you have y is equal to 2x squared plus 4x plus 7, and you differentiate that, you'll get your first derivative again, and that will be called dy dx. If you differentiate it again, you'll get d squared y dx squared. Okay, people find that a little hard to remember at the start, the d squared y dx squared, so write it down a couple of times. You'll get used to it very quickly. Okay, these both mean the same thing. Depending on how complicated the question is, sometimes I'll just use one rather than the other, but you can switch between them. So f of x goes to f dash x when we differentiate it, and y goes to dy over dx when we differentiate it. Okay, but the rules are going to be the same. We're just going to see this notation written down throughout the rest of this video. Okay, now we're going to get straight into it, and we're going to go into differentiating polynomials. Okay, so say if I have this here, we have our f of x equal to 3x to the power of 4 plus 7x cubed minus 9x squared plus 3x minus 10. And I want to differentiate it. Okay, I know when I differentiate f of x, I can write it as f dash x. Okay. Now, that rule I've highlighted in yellow is kind of the key rule for this section. So we're going to multiply the number in front of the x by the power and then reduce the power by 1. Okay, so that's our basic rule for differentiating. Okay, probably the one we're going to see the most often. So multiply the number in front of the x. Okay, so I'm going to focus on this 3x to the power of 4 here. I'm going to multiply the number in front of the x by the power. So our power is 4. So I'm going to multiply 3 by 4. That's going to give me 12. And then I'm going to reduce the power by 1. So instead of x to the power of 4, it's going to be x to the power of 3. Okay, I'm going to do the same thing now with the 7x cubed. So I'm going to multiply the 3 by the 7 to give me 21. And then I'm going to reduce the power by 1, which is going to give me x to the power of 2. Next one then, minus 9x squared. I want to differentiate it. So I'm going to multiply the minus 9 by 2. It's going to give me minus 18. X, and then I need to reduce the power by 1. So it was a 2. It's now a 1. You don't actually have to write in the 1. So we usually just write down x. There's no need for x to the power of 1. Now, for the next ones, okay, when I differentiate 3x, I'm just going to get 3. Okay, why does that happen? I'm just going to kind of do it as a rough work over here. Okay, so 3 to the power of x is the same as 3 to the power of 1. Okay, differentiated, I'm going to multiply the power by the number, that's going to give me 3, and then I'll reduce the power by 1, which will give me 0. Now, anything to the power of 0 is 1, so that's really 3 multiplied by 1, which is just 3. Okay, but I think it's relatively easy to remember. A number with an x will just differentiate to become just the number. Okay, so if there's no power in the x, that's what will happen. And then a number on its own will just disappear when differentiated. Okay, that's a little bit of an oversimplification, but if you just learn that rule, you can't go wrong. So that minus 10 is just when you differentiate, that will just disappear. Okay, so that's our first one differentiated. Now the next one, they tell us that y is equal to 5x cubed plus 6x squared minus 7x plus 20. Now, this time they used y instead of f of x. We're going to do exactly the same thing. When we differentiate it, we'll just call it dy dx. Okay, exactly the same rules. So I'm going to do the first one and then I'm going to try and let you finish it off. So multiply the power by the number. So 5 multiplied by 3 is going to give me 15x. Reduce the power by 1, it'll be to the power of 2. Okay, when you try and finish it off, I'm going to give you a second to try and finish it and then I will fill in the last 2 bits. Okay, so 6x squared, multiply the 6 by the 2, that's going to give me 12. Reduce the power by 1, that'll be x to the power of 1. You usually don't write to the power of 1, not technically wrong if you do. Okay, then minus 7x will just differentiate to minus 7. And then 20 is just gone. Okay, so they are our rules for polynomials. It's really, really important that you can do that quite quickly and accurately as well. Okay, if you are rusty on that, I wouldn't go any further in the video. I'd make sure you know how to do that before we keep going. Okay. So a super common question that all teachers get asked is, why are we learning calculus? What is the point of it? Okay, calculus has a huge range of applications. If you go on to study maths in university, a lot of maths is calculus. Okay, so if you see any of the following words in a calculus question, then you need to differentiate. Okay, so calculus can help us to find the slope. Okay, now if you see this in paper 1, it is a calculus question. In paper 2, it is probably a coordinate geometry question, but we can link coordinate geometry to calculus, as calculus can help us find the slope. Okay, that is what we're going to look at today. It can also tell us if a function is increasing or decreasing. Okay, again, we can just tell that from a slope. So if the slope is positive, it's increasing. We can use it to find a stationary point, a turning point, a maximum point, or a minimum point. So if you have a curve and you want to find out the highest point, okay, or the lowest point, we can use calculus to find that. That is a huge section of calculus. And it can also be used to find the rate of change. Okay, so rate of change is another way of saying slope. But for example, it could be asked, if you were asked to find the rate of change of how the water is flowing into a bucket, for example. Okay, huge amount of applications. You will see that particularly in your section B questions. Okay, so the context and application questions. But what we're going to focus on today is our slope questions. Okay, so if you are asked to find the slope of a curve, okay, so for junior cert, we'll just explain this nice and quickly. So for junior cert, you could find the slope of a line. Okay, you'd know 2 points and you'd be able to find the slope of it. Okay, when things get a little bit more complicated, so I'm going to say we have a curve. Okay, and our curve looks something like this. Okay, and I want to find the slope of the curve at this point exactly. Okay, I don't know 2 points. I can't use my coordinate geometry formula. M is equal to y2 minus y1 over x2 minus x1. Okay, because it's not a straight line. So what we're going to do to find the curve exactly at that point, we're going to draw a tangent. Okay, a tangent is a line that hits the curve at 1 point exactly. Okay, from our tangent, we know this point. Okay, we're going to know that point. And what we need to find then, okay, we need to find the slope. The only way we can find the slope of a curve, okay, what we're going to do, we're going to differentiate the curve and then we're going to sub in the x value of that point. Okay, when we differentiate, okay, the equation of our curve, okay, if you know this x value, you can find the curve exactly, or the slope exactly at that point. Okay, so step 1, we're going to differentiate. Step 2, we're going to sub in the x value of the point we want. Okay, and then that will give us the slope at that point. Okay, these questions then can often go on to ask to find the equation of a tangent. So actually to find the equation of that line, not just the slope at that point, but also the equation it has. Okay, that will link into our coordinate geometry, so no harm to do a little bit of revision at that. So will you be using the equation of a line y minus y1 is equal to m bracket x minus x1 for that. Okay, now this 2020 question, this is actually an ordinary level exam question, but we have to kind of start at this just to kind of get a grasp of what calculus is all about, and it's also good revision for our coordinate geometry. Okay, so find the slope of the tangent to the graph of f of x is equal to 4x cubed minus 3x squared plus x minus 7 at the point 1 minus 5. Okay, so it's a slope question. We're going to follow our 2 steps up there. So first we're going to differentiate. Okay, so this is just differentiating the polynomial. So when I differentiate 4x cubed, I get 12x squared. When I differentiate minus 3x squared, I get minus 6x. When I differentiate x, I get plus 1. Okay, that's my differentiated equation. Now we need to sub in the x value. Okay, the x value at the point we're looking for is 1. So we're going to find f dash 1 is equal to 12 by 1 to be squared minus 6 by 1 plus 1. Okay, I get out there f dash 1 is equal to 7. Okay, so the slope of the curve at the point 1 minus 5 is 7. Okay, so that's part 1 done. Part 2 then, it said hence. Whenever something says hence, you need to use your answer from the part above. Find the equation of the tangent to the graph at this point. Okay, so I'm going to make a very rough sketch. Okay, so not paying too much attention to what the graph actually looks like, but just more for understanding. Okay, so if I have my curve, I'm going to say it looks something like that. Okay, this here is the point 1 minus 5. Okay, we are looking for the equation of the tangent, so the equation of the line that just touches off of this point. Okay, the slope is going to be 7, so we've just found that, so m is equal to 7. We have our point 1 minus 5. That's going to be my x1 and my y1. Find the equation of a line then. My formula y minus y1 is equal to m bracket x1. Sub these in, so it'll be y minus minus 5 is equal to 7 by x minus x1, which is 1. So y plus 5 is equal to 7x minus 7. We can say y is equal to 7x minus 13. Sorry, minus 12. Okay, so that is the equation of the red line that I have drawn there. Okay, so what can calculus be used for? The first thing you have found that calculus can be used for is to find the slope of a tangent. Okay, we're going to do one more question like that. Okay, and a little bit more challenging here. Okay, so find the equation of the tangent at x is equal to minus 2, and you're given y is equal to 2x minus 1 multiplied by 3x plus 7. Okay, equation of a tangent. To find the equation of a tangent, okay, we need, that's just the equation of a line, y minus y1, m bracket x minus x1. Okay, we know our point is minus 2 something. We don't know what the y is. Okay, we don't know what the slope is at all. Okay, so what we need to do, we need to find two things. First, we need to find the slope, and then we need to find the y coordinate. Okay, I'm going to find the y coordinate first, actually. Okay, so we're told in the question that y is equal to 2x minus 1 and 3x plus 7. I know what x is, so just everywhere there's an x, replace it with minus 2. Okay, and put all that into your calculator nice and carefully. There's quite a lot of brackets there. You could do it separately if you wish. Okay, so I get y is equal to minus 5. Okay, so that's my point. To find the equation of a line, you need a point and a slope. I've just found my point there. They kind of gave me half my point. I had to find the other half. Okay, now what we need to do next, we need to find the slope. So we are told y is equal to okay, just for to keep everything the same as the last question, and it's perfectly allowed, I'm just going to change y into f of x. Okay, you should know from functions y is equal to f of x or f of x is equal to y, so we can change those around. Now, I don't particularly like these two brackets. If you are a little bit ahead of this video in class, you may know to differentiate that. You could use the product rule. I'm actually just going to multiply it out just so I can just use my polynomials. You'll get the same answer both ways. Okay, so all I did there, instead of writing y, I wrote f of x. I just prefer writing f of x for these questions because they're going to be subbing in a value. And also I just multiplied it out just to write it in a different form. Okay, now I'm going to find f dash x because to find the slope, we have to differentiate. And this was to find y. So f dash x, differentiate that, you're going to get 12x plus 11. Now we want to find the slope at x equal to minus 2, so we're going to sub in minus 2. Be minus 13. So that is my slope at x equal to minus 2. So I can fill that in up here. M is equal to minus 2. So we'll have y minus y1, m bracket x minus x1. We have our point minus 2 minus 5, x1, y1, and we have our slope minus 2. So I can just fill that in. So it's going to be y minus minus 5 is equal to m, which is minus 2, minus x1, which is also minus, m is equal to, not equal to minus 2. M is equal to minus 13. So it's at minus 2, the slope is equal to minus 13. So then this down here then needs to be minus 13. Okay, make this look a little bit nicer. So it's going to be y plus 5 is equal to minus 13 and x plus 2. Right, now I'm going to have to go up here. So it's going to be y plus 5 is equal to minus 13, x minus 26. So y then is equal to minus 13x minus 31 when you subtract from both sides. Okay, so that is my equation of my tangent there. Okay, so a little bit linking to coordinate geometry, a little bit linking to functions, and a little bit linking to calculus to find the slope. Okay. So first principles is quite an important section of calculus. Okay, you'll do it early on when you are studying calculus in class, but it is a really, really common exam question. Okay, so we're going to go through an example here, and then we're going to go through all the exam questions that have come up the past 4 or 5 times it has come up. They're worth a lot of marks, so I'd really, really encourage you to focus on this and to make sure you are really confident at this. It is a topic that if you see first principles written on your exam paper, that you are able to fly through it. Okay, now we'll be flying through it quite slowly. You'll see the algebra is quite long, but that you're very confident with your method, with your formula, and you know exactly how to achieve full marks or very close to full marks, even if you make a small mistake. Okay, so we'll just take a look at the question before we actually go into what first principles is. So it says differentiate 12x squared plus 2x minus 2 with respect to first principles. Okay, so we are going to be differentiating. Now, if I asked any of you, and I hope from what we did at the start of the video, everyone will be able to differentiate this to, I'm going to write it up here in the corner, f dash x would be 12x squared will differentiate to 24x, and 2 will differentiate to plus 2. Okay, that is the answer. We know that's the answer. We can do that without any method. However, when they say first principles, unfortunately, you will get no marks for just writing down the answer. Okay, what first principles is, it's more of a understanding of why that is the answer. When we apply the rules, you could really learn the rules without any understanding of what calculus is. Okay, what first principles is, it looks at graphing and how you would find the slope of a graph using calculus. Okay, and it uses this formula. We're not going to go into a huge amount. We're just going to look at the focus and the structure of the exam questions. But I guess it is a more theoretical approach, and it looks at more understanding why the answer is 24x plus 2, as opposed to just writing down your answer using your rule. Okay, but it is handy just kind of make even a mental note of what you're expecting your answer should be for all these questions. Just then when you get your final answer, you'll know if you're right or wrong. Okay, so we're asked to differentiate. It says first principles. First thing I'm going to do, like all topics, I'm going to write down my formula. Okay, you need to know that off by heart. So we need all the different parts. So luckily I know what f of x is, so I can just write down f of x is equal to 12x squared plus 2x minus 2. Okay, so I know this part. I need to find f of x plus h. Okay, so if you've done functions before calculus, or even from your junior cert knowledge of functions, you should know whatever is inside in that bracket after the f, you replace your x's with that. Okay, so anywhere I have an x, I'm going to write x plus h in a bracket. Okay, so instead of 12x squared, it's going to be 12 by x plus h to be squared plus 2 by x plus h minus 2. Now, this is where I guess your algebra knowledge comes in. So we need to square this x plus h to be squared, okay? This is going to come up in nearly all our questions. You can nearly learn it off by heart, but I suppose you have enough things to be learning that you may want to just be able to figure it out. But every time you do it, it's going to be the same. So we're just going to square x plus h. So it's going to be x squared plus h plus xh plus xh plus h squared, which is going to give me x squared plus 2xh plus h squared. You can write 2hx either, whichever you prefer. Okay, so instead of writing x plus h all to be squared, it's x squared plus 2xh plus h squared. Okay, we're going to multiply out this next bracket to give me 2x plus 2h minus 2. When multiplying this 12, so this is going to be quite long. It's going to take up the whole screen. So just keep it nice and organized. Okay. I don't think there is anything there that I can tidy up. So that is my f of x plus h. Okay, so I'm just going to highlight what we found. So we know what f of x is. We need that for our formula. And we now know what f of x plus h is. So what I'm going to do, I'm going to put that into my formula and I'm going to tidy it up a little bit. Okay, so we need to find f of x plus h minus f of x divided by h. I'm going to come back to that limit in a second. So it's going to be 12x squared plus 24xh plus 12h squared plus 2x plus 2h minus 2. And from that, we're going to subtract f of x, which is 12x squared plus 2x minus 2. And all of that then divided by h. Okay, very important, don't divide by h too early. Okay, so you can't just kind of cancel things out with the h at this point. Okay, I'm going to tidy this up a little bit. Okay, and that's going to be minus 12x squared minus 2x, and then be very careful there. So it's minus 2, which is going to give me plus 2. Okay, now at this point, things should start to cancel out at the top. So we have 12x squared and a minus 12x squared. We have other things should cancel out. We have a minus 2 and a plus 2. And we have a 2x and a minus 2x. Okay, which leaves us left with 24xh plus 12h squared plus 2h, all to be divided by h. Now, because everything on top has a h, we can divide the h in. So that is going to leave us with 24x plus 12h plus 2. Okay, so this is getting quite long. They do, okay. But once you kind of keep yourself organized, we just have another line or two left to go. Okay, so that's my f of x plus h minus f of x divided by h. Now, there's one thing that I've left out that I said I'd come back to, so that is my limit, okay? We're also going to think about what were we actually asked in the question. So we were asked to differentiate, so we were asked to find f dash x. Okay, going back up to my formula here, f dash x is the limit of h goes to 0 of f of x plus h minus f of x over h, which we have found to be here. So it's going to be the limit of 24x plus 12h plus 2. Okay, now, once you get to this stage, okay, what a limit means, okay, a limit really is looking at what's going to happen as h gets really, really close to 0, okay? So if h is, we're going to say 0.1, okay? H being 0.1 isn't going to affect the 24x, okay? H being 0.1 isn't going to affect the 2. But h being 0.1 is going to make this 12h really, really small, okay? Now, what if h was even closer to 0? So if h was 0.00001, okay? This 12h would be really, really small as well, okay? So basically, as h approaches 0, that 12h is going to get so small. So what we can actually do is we just ignore it, okay? So it's going to approach 0. So 12h is going to get so close to 0. So we're just going to be left with 24x plus 2. As our final answer, which take a look up at our prediction, matches up with our answer. Okay? When we see the marking schemes in a while, the way you write things out is very important, okay? So you need to include this limit as h goes to 0. You can include it up further if you want. I just kind of do all my algebra and all my tidying up, and then I bring in my limit as h goes to 0. Okay, so I do it separately, and then I bring in my limit. Okay, and then you have your final answer, f dash x is 24x plus 2. A lot of people kind of think this is a big waste of time. We knew that answer from the start. But it is quite a likely question on your exams when we see the trends now. It comes up a lot. So we're going to start with the 2022 question. So differentiate f of x is equal to 2x squared plus 4x with respect to x from first principles. Key thing there, differentiate and first principles. First thing I would be writing down is my formula. Okay, so the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, that's your key start. It is, you need to find all those parts individually and then put it together. Okay, so we need to know that formula off by heart. That is not given to you anywhere. Okay, what I am going to do up here in the top corner, I'm just going to make my little prediction. So f dash x should equal, we differentiate 2x squared, you'll get 4x, and differentiate 4x, you'll get plus 4. Okay, that's the answer I'm expecting at the end. So now, we know f of x is 2x squared plus 4x. Next thing we need to do is we need to find f of x plus h. So everywhere there's an x, replace it with x plus h. Okay, we're going to multiply this out. So when we square x plus h, we get x squared plus 2xh plus h squared. A very common mistake, and I think it comes more from rushing than anything else. When people square x plus h, they tend to get x squared plus h squared. Unfortunately, that isn't right. Okay, and you will be losing quite a few marks there because the rest of your answers will be wrong, and you will get into a mess because you won't be getting the answer you expect. Just make sure when you square x plus h, if you do need to do it out on the side, which is a bit of rough work, going like x plus h by x plus h, it only takes that extra bit of time, but it might be worth it just to ensure you don't make that mistake. Okay, and that's my f of x plus h. Okay, so now I have my f of x, and I have my f of x plus h. We're now going to put it together. So we need to find f of x plus h minus f of x all divided by h. So it's going to be 2x squared minus f of x, which is 2x squared plus 4x. All divided by h. Now I'll just write this out without the brackets. And like the first example, it will always be in this line that things will cancel. So the 2x squared will cancel, plus 4x and minus 4x will cancel as well. So we're left with 4xh plus 2h squared plus 4h to be divided by h. Divide h into everything there, that'll be 4x plus 2h plus 4. Okay, so that's my f of x plus h minus f of x all divided by h. Now, I've kind of ignored the limit up until this point. We need to write that down, okay? So we need to write down that we're going to have our limit as h goes to 0 of 4x plus 2h plus 4, okay? So that 4x isn't going to be affected if h gets really, really small. Neither is the plus 4. But as h gets really, really, really small, okay, that 2h is going to get really, really close to 0. Okay, so our final answer is 4x plus 4. Take a look up to the top at our prediction. That is our correct answer. Okay, so quite a lot of work. We're going to take a look at the marking scheme and see how we would have done. Okay, so this was worth 15 marks, which is quite generous. Okay, so 15 marks. So first thing they say on the right hand side, note no credit unless differentiation from first principles is being used. So if you just write down the final answer, you won't get anything. Okay, for some topics, if you don't do the correct method or if you don't show your work, you will get some marks for writing down the final answer. Here, you won't get anything. Okay, and that has been a trend every time it has come up, really. Okay, so they want the 4 steps. They want you to find f of x plus h, which we did. They then want you to find f of x plus h minus f of x. Did that as well. And then find f of x plus h minus f of x divided by h, and then put in your limit. Okay, so that would get you your full marks. What you can get here, you can get 0 marks. To get 0 marks, you would either have to make no attempt or not use first principles. To get 4 marks, okay, so you tried to do something about x plus h. Okay, so you tried some substitution into f of x plus h. If you want a mid-partial credit, so to get 8 marks, you need 2 steps correct. Okay, to get your high partial credit then, to get 12 marks, you need 3 steps correct. or the left-hand side missing, otherwise correct. Okay, so if you didn't include your limits somewhere in the question, then you would be not getting full marks either. Okay, so I suppose it is possible here to get out your right answer at the end, but if you don't have things written out correctly, then unfortunately you will be losing some marks. Okay, so that's the 2022 question. We're going to go on now and do the next one. Okay, so this also came up in 2020. Again, it says first principles. The first thing I'm going to write down is my formula. Okay, now you'll notice that this question looks a little different. Okay, there's brackets involved. If you've done, if you're a bit into calculus in school, you may know if you want to differentiate that normally you'd use the product rule because they're being multiplied. But for our first principles, we've no way of using the product rule. Okay, so the first thing I'm going to do, okay, I'm going to make that look a little nicer. Okay, so instead of writing it as 3x minus 5 multiplied by 2x plus 4, I'm just going to multiply out those brackets. Okay, I like when things are just kind of a normal, straightforward, quadratic or cubic. I don't like it with the bracket for first principles. We don't know how to do that, so we're just going to get rid of it. Okay, it'll make the question a lot nicer. So do out our multiplication. Okay, so instead of writing it as 3x minus 5 multiplied by 2x plus 4, we can write it out instead as 6x squared plus 2x minus 20. Okay, so my new f of x is 6x squared plus 2x minus 20. Now we need to find f of x plus h, so everywhere there is an x, replace it with x plus h. Okay, and from here, just more multiplying out. This does get a little bit repetitive, but it is really important to practice them. Okay, so that is my f of x plus h. Okay, so I found my f of x. Had to do kind of an extra step, but really isn't adding much to your workload. And then I have my f of x plus h here. Now we're going to fill it into okay, so here with the first bracket will always be fine, nothing will change there. With the second bracket, we'll just have to be a little bit careful with our signs here. Okay, so it's going to be minus 6x squared minus 2x, and then minus plus 20. Okay, things will cancel, so my x squareds will cancel, my 2x and my minus 2x and my minus 20 and my plus 20. So I'm just left there with 12xh plus 6h squared. And my plus 2h. Okay, divide the h into everything there, you'll get 12x plus 6h plus 2. Okay, now we want to know what happens is the limit as h goes to 0 of 12x plus 6h plus 2. So what's going to happen is h gets really, really small. That 6h is also going to get really, really small. So our answer is just 12x plus 2, which if I go back up to this here, this is what we were actually differentiating. 12x plus 2 would be your expected answer. Okay, so then we can write f dash x is equal to 12x plus 2. Okay, so again, look at the marking scheme. 15 marks as well. So to get 5 marks, you need some substitution into f of x plus h. To get your high partial credit, so if you get 10 marks for getting down as far as, where do we have that now? So this line here will get you your 10 out of 15 marks, okay, which is quite a lot. So no credit if you don't use first principles. Okay, so if you don't use first principles and you just get your answer, then you will not get any marks at all. Okay, so really important there, just make sure you, even if you don't get to the end, that you're using your first principles, because you can get even 5 out of 10 marks or 10 out of 15 marks just for kind of having the structure of the first principles question. Okay, so that was 2020. Going to move on now to 2017, which I think looks a little bit more intimidating, okay? And I suppose it is because of the fraction. Now, there is nothing we can do here with the fraction, okay? We cannot multiply everything across by 3, okay? You're not allowed to do that. You're only allowed to do that if there is an equal to sign and you can do it to both sides, okay? Unfortunately, we don't have an equal to sign here. You won't for any of these, so we cannot change it, okay? Don't let the fraction throw you off, okay? We're going to have fractions the whole way through this question. So we're going to do it a little bit slower, okay? Just to make sure we don't make a little mistake. Okay. So again, it says first principles. First thing, I'm going to write down my formula. So if I want to differentiate something using first principles, the limit as h goes to 0. Okay, so that is my formula. Next thing now, we'll write down what my f of x is. And then we need to find our f of x plus h. So everywhere even x, you should be getting into the pattern of this now. Everywhere even x, replace it with x plus h. Okay, x plus h to be squared, you probably know at this stage, it is x squared plus 2xh plus h squared. Okay, be careful here now, we have minus outside our bracket, so it's going to be minus x minus h plus 3, and we need to multiply that 1/3 into our bracket. Okay, so it's going to be 1/3 x squared plus, now if you're unsure of this, just fire it into your calculator. 2 multiplied by 1/3 will give you 2/3 xh plus 1/3 h squared minus x minus h plus 3. So that is my f of x plus h. So I have my f of x and I have my f of x plus h. Now we're going to put those together into our formula. So we're going to do f of x plus h minus f of x divided by h, which is, okay, so nice and carefully, so it's 1/3 x squared plus 2/3 xh plus 1/3 h squared minus x minus h plus 3. And we're going to subtract f of x, which is 1/3 x squared minus x plus 3. Okay, now the first bracket there won't change, so it's going to be 1/3 x squared okay, and then it's going to be minus 1/3 x squared, and then minus by minus is going to be plus x minus 3. And then we're going to do our cancelling. So our x squareds will cancel, our plus 3 and our minus 3 will cancel, and I have a minus x and a plus x, which leaves me with 2/3 xh plus 1/3 h squared minus h. Okay, and then we want to find the limit as the h approaches 0. Oh, sorry, we need to divide that by h first. Sorry, going back, we never divided here by h. Okay, so that's going to give me 2 over 3x plus 1 over 3h minus 1. Now this is where you find the limit as h goes to 0 of that. Okay, if h is really, really close to 0, it's not going to affect that 2 over 3x. If h gets really, really close to 0, that 1/3 h is going to get really, really close to 0 as well. So that's going to be gone. And then that minus 1 also won't be affected. Okay, so our f dash x then is equal to 2 over 3 x minus 1. Okay, as my final answer. We're just going to go up and we're just going to make sure that's correct. Okay, so what do we start with? 1 over 3x squared minus x plus 3. If you differentiate 1 over 3x squared, multiply the 1 over 3 by 2, that's going to give me 2 over 3 x, reduce the power by 1, that'll just be x. And then differentiate minus x, that'll be minus 1, which is the same answer as what we got below. Okay, getting the same answer or the correct answer unfortunately doesn't guarantee you full marks. So, you know, in some questions, if you get the right answer, you can always say, okay, that's definitely correct. Here, because it's kind of a formal, almost proof method, so there's a very strict structure to it. You may have it correct and you may have the bulk of it correct, but say, for example, if you forget to include your limit, you won't be getting full marks. Okay, again, we'll take a look at the marking scheme for this. So this time it was actually worth 20 marks. Okay, so 0 marks if you don't include first principles. So down there at the bottom in the notes, answer not from first principles merits 0 marks. Okay, so if you don't use first principles, you just write down the answer. Unfortunately, you're getting 0. To get a low partial credit, so 5 marks if you did something about the f of x plus h. Okay, mid partial credit then to get 14 marks, f of x plus h minus f of x with some correct work. Okay, so you knew where you needed to go with the question. And then the high partial credit, if you had, where is that line now? If you got as far as here and you started to simplify it, okay, that would have gotten you 17 out of 20. And then finally, to get your full marks, obviously you need it all to be correct. Okay, so 20 marks there. That would have been out, so that was before the changes to the paper before COVID, so that would have been a 25 mark question, so 20 out of the 25 marks for your first principles. It is a very, very important skill. Okay, we're going to do one more. So that was 2017. Now we're going to look at the 2016 one. Okay, so I'm going to get us started on this, and then after that, I would really, really encourage you to pause the video and give it a go. Okay, just looking at this question now, you should notice something a little bit different about this question. Okay, so on first glance, I can see that it doesn't look like a nice one. Okay, so it's all in a bracket and it's to be squared, but it's a relatively easy problem to fix. Okay, so instead of writing it as 2x plus 4 all to be squared, I can write it as 2x plus 4 by 2x plus 4. Now you might be able to square this out quicker than doing this method, as long as you get the same answer. That is fantastic. So it's going to be 4x squared plus 8x plus 8x plus 16. So instead of writing it out the way that they had it, okay, with the squared, we're going to change it into 4x squared plus 16x plus 16. Okay, what I'd like you to do now is to give this question a go. Okay, make sure you're writing down all your details and you're writing it out perfectly to get your full marks if it was in an exam. Okay, and I'm going to go through it now in just 1 second. Okay, so first thing I'm going to do, I'm going to write down the formula. Okay, we're going to write down what our f of x is. So we're going to write it down in our simplified version. So I'm going to forget about that 2x plus 4 to be squared. And instead write down 4x squared plus 16x plus 16. Next step then, we should nearly know this off by heart by now. We are going to write down our f of x plus h. When I square x plus h, I get x squared plus 2xh plus h squared plus 16x plus 16h plus 16. Okay, multiply this 4 in, and then I will have my f of x plus h. Okay, and now I am ready. I have my f of x and I have my f of x plus h. I'm ready to fill it in to f of x plus h minus f of x divided by h. So it is going to be 4x squared At this point, things should cancel. Okay, if the things don't cancel at this point, you've made a mistake, probably with your signs. Okay, so there's probably a minus sign there that you didn't multiply into a bracket or something, but at this point, a lot of things should cancel. That leaves us with 8xh plus 4h squared plus 16h. All to be divided by h. Divide the h into everything. That'll give me 8x plus 4h plus 16. Okay, not finished. We then need to find the limit as h goes to 0 of 8x plus 4h plus 16. So the part with the h is going to disappear, so we're just going to be left with 8x plus 16. So f dash x, the differentiated version, is 8x plus 16 as my final answer. I'm going to go up now and see if that was our predicted answer. So this is what we were differentiating here. If I differentiate 4x squared, I end up with 8x. Differentiate 16x, we'll get 16. So 8x plus 16 is our expected answer, which we got. Okay, I don't have the marking scheme for that, but it was, again, 15 marks. And the same thing, you don't get any marks if you don't use first principles. Okay, so I hope you can see from that, those couple of questions that we did, very repetitive, okay, nearly always the same thing, okay. The only way they can change it, if we look at the 2016 question, they gave it to you in a little bit messy form. You had to do that extra step, same as what they did in the 2020 question. You just have to multiply out the two brackets. Okay, the 2017 question looked a little bit more daunting with the fractions, and I think that might throw a few people, especially under the pressure of an exam. But just take your time with it. It actually doesn't make it any more difficult. Okay, just a little bit messier maybe. Okay, very common. So that was 2022, 2020, 2017, 2016. It is a very common exam question. It is something I would be going into my exam being very confident about. Okay, so that brings us to the end of this video. We'll just do a quick recap of what we went through. So we started with just an introduction to calculus, your notation, and your basic rules for differentiating polynomials. Okay, you are going to need that rule throughout. Okay, there are going to be harder rules for differentiation, so the chain rule, the product rule, the quotient rule, but even within those, you need to be able to differentiate your polynomials, so it's really, really important. Okay, Second, then what we did, we used calculus to find the slope, and we did a bit on coordinate geometry, just a small bit on finding the equation of a line. Again, really, really important just to show an application. There are going to be loads more applications, okay? So if you're only starting your study of calculus, calculus can do a lot more things than you probably think it can, okay? And then we focused on differentiating by first principles, and we did a load of exam questions. We practiced our structure and we looked at the marking scheme. So what do you actually need to achieve full marks? Okay, attention to detail is needed here, and make sure you have a nice structure on your questions. Okay, and then you will get very high marks in these type of questions. Okay, first principles is the type of thing that if you work hard in it, you will reap the rewards. You will get your marks in that question if it comes up. Okay, thanks guys, best of luck. And with regards to moving on with calculus, there will be another video with that goes through the calculus rules that kind of links up with this video.